Great circle routes on the parallel of latitude. This is a continuation of where we stopped in the last video, but in this video I'm still going to make emphasis on the two formulas particularly, especially the split method and the direct formula method. So I'm going to take two examples more, and on those two examples I'll be looking at the two methods again. So if you didn't get the how to use the split method, if you didn't understand how to use the split method in the first video, you are going to have a chance of knowing how to use the split method in this video, because I'm going to use I'm going to do it 2 times. That means I'm going to take 2 more examples in this video that specifically I will use the 2 methods on those 2 examples. So let's proceed. Point number 1, point A 60 degrees north, B 34 degrees west, and B 60 degrees north, 70 degrees east are 2 places on the Earth's surface. So if I don't come here. So 60 degrees north, yeah, 60 degrees north, 34 degrees west, so longitude 34 degrees west. So this point A, point B is 60 degrees north, 70 degrees east. This is longitude 70 degrees east, and this is point B. So A and B obviously are lying on the parallel of latitude. So this is the center of a small circle. Alright, so now we're trying to calculate the distance AB along the parallel of latitude. So A along the parallel of latitude, so the arc AB is so A is longitude 34 degrees west, 34 degrees west. B is 70 degrees east. Alright, so angular difference in longitude, so it's equal to 34 degrees plus 70 degrees. That's equal to 104 degrees. The next thing is to get the distance AB along the parallel of latitude. So distance AB along parallel of latitude, 60 degrees north, actually 60 degrees. Times 2 pi cos alpha. So this will give us the distance is 104 degrees, actually 60 degrees times 2 times 22 over 7 times 6,400 times cos 60 degrees. Alright, so this will give 104 times 2 times 22 times 6,400 times cos 60 1 4 643,200 divided by 32520 divided by 2520 equal to 5,810.79 kilometers, which approximately is equal to the three significant figures. We're going to have 1, 2, 3, 5,810, 5,810 kilometers. The three significant figures. So that's the distance AB along the parallel of latitude 60 degrees north. Alright, so let's go to B. Now B says we should calculate the distance AB along great circle. So anytime 2 points are aligned in the parallel of latitude and we are asked to calculate the distance between those 2 points on the great circle, it means we're going to use a formula. No, we are still going to use the same formula, but our working or the procedure will be different from how we were going to solve, or how we should have solved the question if the 2 points were lying on the same longitude or measured from the equator. So because the 2 points are lying on the parallel of latitude, we are going to have to solve it either using the direct method or the split method, because what we have in this case is that, first of all, the same arc, which is AB, which is the arc of the circle, a small circle. Point AB is the arc of the parallel of latitude, which is the arc of the small circle. It's also the same arc if we bring it to the equator. So we have two different arcs AB. So one from the small circle we have this. So let's call this figure 1. So let's call this A, B. So this figure we have from here we get our length of chord. Let's call this X. Our length of chord. Now the angular difference in longitude will give us the angle here. Remember, the whole of it is theta, which is the angular difference in longitude, and theta divided by this perpendicular line will give us this one, or rather this perpendicular line will divide the angle, which is the angular difference, into two equal parts. So 104 degrees divided by 2 will give us 52. So here is 52 degrees and here is also 52 degrees. So this figure 1. Then this arc AB is the distance. The arc AB is the distance between A and B along the parallel of latitude 60 degrees north. Now on this same part, this same arc is also the distance between AB from the equator, which is the great circle route on the parallel of latitude. So we're going to have another arc here from the great circle. We'll call it figure 2. Okay, so this is, and then this is our chord. Alright, so this is A, B, and this is what we are looking for, this distance AB. For us to be able to get distance AB along the great circle, we need that information from the small circle, and that's the length of chord from the small circle. So let's just call this A. That's the half the distance between A and the length of chord here is XB. So let's call here alpha, which is the angle here, alpha, the angle here, alpha, which is same thing, alpha, which together alpha plus alpha will give us 2 alpha. So we need information here to help us to get the distance AB along the great circle route. This is the great circle route, this is the parallel of latitude. Alright, so let's call this figure 2. Alright, now let's proceed. Now from figure 1, we're doing the same. This, what I'm doing now is a split method. So let me write it down. This is split method. Split method. Okay. It implies that you're splitting you split the shape here into two different parts, where this first ACB, so this is ACB, a small circle route ACB. C is the center of the small circle, which is this C here, and write it out. And O, here's O. O is the center of the great circle. So here's AOB. This is ACB and AOB. Alright, so from figure 1, the length of the chord, AB is equal to 2R sin theta over 2, but R is equal to R cos alpha. So the formula becomes 2R cos alpha sin theta over 2. Theta is the angular difference between the angular difference in longitude is 104 degrees, and we've already done that to give us 52 degrees. So we're not going to waste time here. So this will give us, we already know that cos alpha is a parallel line of latitude, common parallel line of latitude on which 2 points are lying. So 2R is 6,400, 2 times 6,400 times cos 60 degrees times sin theta over 2 is sin 104. Let me just write it. Sin 104 degrees. Theta is angular difference. It's 104 degrees divided by 2. So this will give us 2 times 6,400 times cos 60 degrees times sin 52 degrees. So 2 times 6,400 times cos 60 is 0.5 sin 52. 0.7880, 0.7880. So 2 times 6,400 times 0.5 times 0.7880. That's 5042.2 kilometers. So that's the length. This is the length of the chord, and we're going to need this value here. Now we're told to calculate the distance between AB along the great circle. So along the great circle, this value here will be useful here because we still have the same length of chord AB in the great circle route. But before we are going to do so this length of the chord in figure 1, in figure 2. First thing first, we're going to say distance AB along a great circle is equal to. So we're going to get the complete the total angle from B, that's angle AOB. The angle AOB, which is equal to 2 alpha over 360 degrees times 2 pi r. That is seen from a triangle. So we're going to make this triangle now from triangle A, or from triangle O, OAB, using sine ratio. We're going to have from sine ratio, we're going to have sine alpha. That's what is triangle O. From triangle OXB, that's what we're going to look at, not OAB. OAB is the total angle from this line to this line, so which gives us 2 alpha. That's the angular difference in latitude. Alpha will give us 2 alpha here over 360 degrees, which is the total angle here, and then this arc. So we are considering this arc, the length of arc, the distance between A and B, which is the great circle distance. But to get alpha is why we are using triangle OXB, using sine ratio. Sine alpha is equal to opposite. Now opposite is XB over hypotenuse, or photo. This is the radius of the Earth because this is to equator. While here this is small r, So hypotenuse is r over hypotenuse. So xb is half the length of chord AB. Take note, the length of chord AB is from A to B. Half of it is xb. So sine alpha, this will give us half. Now this was what I said that we needed to get the length of chord because the value of the length of chord would be useful here. So this is where it would be useful. Our xb is half 5043.2 over r, which is 6400. So sine alpha is equal to divided by 2521.6 divided by 6400. The sine alpha is equal to 6400, 0.394. 0.394. So alpha is equal to arc sine 0.394, and alpha is equal to shift sine 0.394, 23.2 degrees, 23.2 degrees. So if alpha is 23.2 degrees, that is only this angle from B to this parallel line, this vertical line is, as alpha alone is 23.2 degrees. So let's come back to our formula, which here we have 2 alpha. Now that we've gotten the value of alpha, we can proceed with distance AB along a circle. So distance AB along a circle is equal to 2 alpha for 360 degrees times 2 pi r. So the value of alpha is known, which is 2 times 23.2 degrees over 360 degrees times 2 times 6400 times of 22 over 7 times 6400, and that is equal to 23. 2 times 23.2, 2 times 23.2 is equal to 46.4 times 2 times 22 times 6400 times 130,66240 over 360 degrees times 7 equals 2520, and that's equal to 5185.02 kilometers approximately. The three significant figures 1, 2, 3, 5, 1, 90, 55,190 kilometers to 3 significant figures. So this is the distance AB along the great circle. If you don't want to use the split method, you can use the other method to get AB along the great circle, and that other method is known as the direct formula method. So I'm going to say the split method, direct formula method. Okay, and that is the AB along great circle is equal to distance AB along great circle equal to 2 arc sine cos alpha sine theta over 2 times 2 pi r over 360 degrees. So this is a formula. and AB is equal to 2arc sine cos alpha. Cos alpha is parallel of cos 60 degrees, which is the parallel of latitude on which A and B are lying. Sine theta is the angular difference in longitude between point A and B, which is 34 degrees west and 70 degrees north, and that's equal to 104 degrees over 2 times 2 pi r times 2 times 22 times 22 over 7, 22 times 6,400 over 360 degrees times 7. That will give us 2arc sine cos 60 degrees 0.5 times 104 divided by 2 is 52 degrees of sine 52. 0.7880 times 2 times 22 times 6,400, 2 times 22 times 6,400, 281,600, 281,600 divided by 360 degrees times 7 is 2520. So 0.5 times 7, 0.7880, 0.394. 2arc sine 0.394 times 281,600 divided by 2520. Okay, let me wipe this out. Next is to get the value for arc sine, which is this. So arc sine 0.394. Arc sine 0.394. That's 23.20. So that gives us 2 times 23.20 degrees times about 281,600. This is the value gotten from 2 pi r, which is 2 pi r. 2 times 22, then the 7 is the denominator, so that's what we have here. 22 times 22 times 6,400. Then 360 degrees times 7 give us 2520. So we have here 2 times 23, 2 times 23.2 times 281,600. That's 130,130,66,240 divided by 2520, and that will give us 2520. 5185.02 kilometers approximately. So 3 significant figures: 5190 kilometers. So 3 significant figures. So this is the form of, this is the answer when we use the direct formula method, and this is the answer when we use the split method. So compare the two answers. First of all, let's compare the answer here: 5185.02 kilometers, 5185.02 kilometers, and then the 3 significant figures we have here: 5,190 kilometers to 3 SF, and here 5,190 kilometers to 2 SF. So the answers are the same. So in this example, we are still going to mix the two. I'm still going to use the 2 formulas to solve the great circle route or distance of 2 points along great circle. But first of all, let's draw the circle of latitude. So find the distance between P 50 degrees south, 90 degrees west, and Q 50 degrees south, 90 degrees east along a Roman figure 1 circle of latitude and Roman figure 2 great circle. Take pi to 22/7 and r 6,400 kilometers. So let's get the sketch of a diagram of the diagram. This equator, so 50 degrees south. Okay, and this is the center of the small circle. C. This is the center of the great circle. O. So 50 degrees south, we have then this is latitude. 50 degrees south. Okay, so point P is 90 degrees west. 90 degrees west. Longitude 90 degrees west. So this point P. And point Q is 90 degrees east. Longitude 90 degrees east. So where is point Q? Alright, so from this a small circle route. Okay. Distance along small circle. So I say distance EV along circle of latitude. On circle of latitude 50 degrees south, equator 6 latitude 60 degrees times 2 pi r cos alpha. So the angular distance, so EQ difference in 90 degrees, 90 degrees, that's 180 degrees. Angular distance, angular difference, the angular difference in longitude is equal to longitude equal to theta 90 degrees plus 90 degrees, and that's equal to 180 degrees. Now that implies that, okay, so distance AB, so AB is equal to 180 degrees over 260 degrees times 2 times 22 over 7 times 400 times cos 50 degrees. 180 here is 1, 180 is 2, 2 here, 1, 2 here, 1. So we have 22. 22 times 6,400 times cos 50, 90, 9050, 90,504.50 divided by 7. And that will be equal to 90,504.50 divided by 7. 12929, 12929.21 kilometers approximately. So 3 significant figures: 1, 2, 3, 1,003, 13,000 kilometers. So 3 significant figures. So number figure 2. So split method, we're going to have For the split method, we're going to have two shapes. So the split method. Alright. So now for the split method, and because our shape is like this, we can still okay. Now another way to represent this so that it will be okay for us to sketch the great circle route is that PQ can be here. We have PQ. It's still the same thing. So these are centered from the great circle, and from this. Alright, so now this same point of the great circle is alright. So from our great circle, so we have here from figure 1. So the PQ along a small circle is this shape and this arc. So we're going to have figure 1, PQ, and then we're going to have our length of chord, and then the perpendicular, so call is X, and then this arc PQ, which is the distance between PQ along the parallel of latitude. So the center is C. Center C. And here we call this figure 1. And figure 2, which is the great circle route at POQ. Is Q not POQ. Okay. So this time around, PQ is this way, like this. So this will give me draw it again. So these are small circle routes PQ on parallel of latitude. This is the arc. So P. So this is the center of the small circle because this time around is like this. This is the arc. Okay, so I'll call this figure 1. And our great circle route is like this. Because this time around is from equator to PQ, which is the parallel of latitude, the same line. So the center is O, PQ, and then the parallel, the perpendicular X. Okay, and this is what we are looking for, this distance. Let's call this figure 2. Alright, and we need to know alpha. So here in this figure, we are going to look for the length of chord. So let's proceed. Figure 1, length of chord. Length of chord PQ. PQ is equal to 2 R sine theta over 2. But R is equal to R cos alpha, which is also R cos alpha sine theta over 2. 2 times 6,400 times cos 50 degrees times sine 180 degrees over 2. 2 times 6,400 times cos 50 degrees times sine 90 degrees. 2 times 6,400 times cos 50. 0.6428. 0.6428 sine 90 degrees. So 1 times 1. So 2 times 6,400 times 0.6428 times 1. 8227.84 kilometers. That's the length of the chord. Alright, so now let's come to figure 2. So from figure 2, we need to know the value of alpha using sine ratio. So sine alpha is equal to opposite, which is opposite here because xq half the chord xq over r, radius of the earth hypotenuse, and this is the radius of small circle, radius of great circle r, and this xq is half pq over r, and this is half 8227.84 divided by 6,100. 4113.92 divided by 6,400. 0.6428. 0.6428. So alpha equal to arcsine. Arcsine 0.6428. Alpha is equal to 40 degrees. Okay, alpha is equal to 40 degrees. Distance AB along the circle. Along the circle is equal to 2 alpha, which in this case the angle, which is angular difference in latitude. This is alpha, so here also be alpha is equal to 2 alpha over 360 degrees times 2 pi r. So now 2 alpha, the distance AB, so 2, the alpha is 40 degrees, so 2 times 40 degrees over 360 degrees times 2 times 22 over 7 times 6,400. So 2 times 40 is 80. Okay, then you have 80 degrees over 360 degrees times 2 times 22 over 7 times 6,400. So 80 times 2 times 22 times 6,400. That is 2252. 22528000 over 2520 divided by 2520. 8939. 8939.68 kilometers. Approximately the three significant figures 1, 2, 3, 8940 kilometers to SF. So this is what you this the value from the split method. So the next method we're going to use is the direct formula method. Direct formula method. Okay, so distance AB along great circle equal to 2 arcsine cos alpha sine theta over 2 times 2 pi r over 260 degrees. So 2 arcsine cos 50 degrees times sine 180 degrees over 2 times 2 times 22 times 6,400 times 6,400 over 360 degrees times 7. This 7 is coming from 22, which is 22 over 7, so 7 is the denominator, and that is equal to 2 arc sine cos 15 degrees times sine 180 divided by 2 will give us 90, sine 90 degrees times 2 times 22 times 6,400 divided by 360 times 7 gives 2520. So now 2 arc sine cos 50 cos 50 0 point cos 50 0.64 0.6428 times 1 times 2 times 2 2 times 22 times 6,000 2 times 22 times 6,400 281 600 divided by 2520 equals to, so arc sine, straight arc sine 0.64 0.6428, that's 40 degrees. 2 times 40 degrees times 281600 divided by 2520. 2 times 40 will give us 80. 80 times 281600, that's equal to, then divided by 2520, 8939 8939.68 kilometers. So approximately, to three significant figures, 1 2 3 8940 kilometers to three significant figures. So let's look at this. What we have here is same as what we have here, and when we round, when we get correct our answers to three significant figures, this is what we have: 8,940 kilometers, and that's also what we have here: 8,940 kilometers. So both methods will give you the same answer, but like I always say, use one of the methods. You are not expected to use the two methods in an examination condition. So I just did this for illustration purpose. A, latitude 4 degrees north, longitude 15 degrees east, and B, latitude 4 degrees north, longitude 40 degrees west are 2 points on the Earth's surface. Calculate to the nearest kilometer the distance along the parallel of latitude, a great circle. So 4 degrees north, latitude 4 degrees north, and point A, longitude 15 degrees east, longitude 15 degrees east. This point A. Point B is longitude 40 degrees west. This point B. Point B. A and B are on the parallel of latitude. So the center of the small circle is C, and the center of the great circle is O. So when you say A, or remember figure 1 says on the parallel of latitude. So the first thing we're going to do is to get our angular difference. Angular difference in longitude is equal to, which is theta, is equal to 40 degrees plus 15 degrees, 55 degrees. 40 degrees, 15 degrees, 55 degrees, C A B. Okay, so the distance AB along parallel of latitude, latitude 4 degrees north, equal to theta, material 60 degrees times 2 IR cos alpha. The theta is the angular difference is equal to 55 degrees, material 60 degrees times 2 times 22 over 7 times radius of the earth 6,400 times cos 4 degrees. 55 times 2 times 22 and 6,400 times cos 4. 15450,272.01. 360 times 7 is 2520. Divided by 2520. 6131.06 kilometers. So to the nearest kilometer, approximately it's got 6131 kilometers. So the nearest kilometers. Then over figure 2, along a great circle. So along a great circle, and then to equator. Right. So I'm going to use the direct formula method. Using the direct formula method. So distance AB, distance BA. So okay, since it as AB, distance AB along with circle equal to 2 arc sine plus alpha sine theta over 2 times 2 pi r over 3 60 degrees. 2 arc sine cos 4 degrees times sine theta is 55 degrees times 55 degrees over 2 times 2 times 22 and 6,400 over 360 degrees times 7 2 arc sine cos 4 0.9976 times sine 55 degrees divided by 2. Okay, that's here. So I say cos 4 degrees times sine 55 divided by 2 is 27.5. Sine 27.5 degrees times 2 times 22. 44 times 6,400. 281. 281,600. 2520. 2 arc sine. So let's get the values. Cos 4 0.9978 0.9978 times sine 27.5 0.4617 0.4617 times 281 times 281,600 over 2520. The 2 arc sine 0.9987 78 times 0.4617 0.9978 times 0.46117. That's 0.4607. 0.4607 times 281,600 over 2520. 2520. So 2 arc sine 0.467. So arc sine 0.4607, 27.4 times 27.4 degrees times 281,600 divided by 2520. So 2 times 27.4, that's 54.8 times 281,600. That's equal to 151,680 divided by 2520. So divided by 2520, 6123, 6123.68, 6123. So approximately, so the nearest kilometer is equal to 6124, 6124 kilometers. So the nearest kilometer. An airplane flies due west for 3 hours from P, latitude 50 degrees north, longitude 60 degrees west. So P is latitude 50 degrees north. 50 degrees north, and longitude 60 degrees west. This point P and Q, the point Q at an average speed of 6,400 kilometers. So which means from P, the flight field from P to Q. So this point Q. So this is a flight movement. And then question says, the airplane then flies due south from Q to a point Y. Point Y. So due south from here, due south, point Y. Okay, so that's all. Remember, A says the longitude of Q. So A. And we got it from QP, from distance QP, distance QQ along the parallel of latitude. And parallel of latitude 50 degrees north, which is equal to 6 over 2, 60 degrees times 2 by r cos alpha. So here, so we're going to get theta. Now we're told that the speed of we're giving the time that the airplane flew from P to Q, and also the speed. So So to get the distance, but the distance is equal to speed times time. So the speed is equal to 600 kilometers times time, which is 3. And that's equal to 1,800 kilometers. So distance PQ is equal to 800 kilometers. So here theta, let's get the value of theta. So 1,800 is equal to theta over 360 degrees times 2 pi times 2 times 22 over 7 times 6,400 times cos 50 degrees, which is the line of parallel of latitude on which P and Q are lying. Alright, 50 degrees, 1,800 is equal to 2 times 22 times 6,400 times cos 50, 1,181,008.99 theta over 2520. So cross multiplying 1,800 times 2520 equal to 181,008.99 theta. So 2520 times 1, 4. So theta is equal to 453,600,0081008.99. So theta is equal to divided by 181,008.99, 25.06 degrees. Therefore longitude of Q is 16 degrees minus theta. That is 60 degrees minus 25.06 degrees. That's equal to 60 minus 25.06. That's 34.94 degrees. Now let's see. Latitude of Y can be gotten from distance PY along the line of latitude, along the line of longitude, and that's equal to theta, which is 60 degrees times 2 pi r. So we're sure that the distance from Q to a point Y is 500 kilometers. So the distance QY is equal to 500. The Q, yeah, distance QY. So that is of Y can be gotten from distance QY. So QY is equal to 500 kilometers. And so 500 is equal to theta over 260 degrees times 2.22 over 7.67400. 500 is equal to 2 times 22 times 6,400 28,600 theta over 250 cross multiplying 2520 times 500, 281,600 theta. So theta is equal to 2520 times 500, 126,000, 126,000 divided by 281,600. So theta divided by 281,600, 4.47 degrees. Therefore, the latitude of one is 50 degrees minus 4.47 degrees. (45.53 degrees). So why do we subtract